Okay, this is concept 47. In this one, we learn how to solve exponential equations using logs. For the first one, I did not solve this one because this one it's one of the basic exponential equations we've looked at in the previous concept. So just see if you can solve it. Hopefully, you're good with this. For this one, I have 9 raised to a plus 2 and then 27 to 4a minus 2. I can rewrite 9 and 27 as base 3's. So 3 squared is 9, 3 to the third is 27, and then I work out these exponents. So I have the same base, they're equal, so then the exponents must be equal, and then when I solved, I got that a is equal to 1. So again, this is from a previous concept. For this new one, okay, says what if a common base is not possible? So in other words, you have two sides that are, you have some exponential expression like number 3 here, you can see at the bottom, okay, but there's no way you can write 61 as a base 2 so that you can work out the exponents. So when that happens, what you want to do is isolate the exponential expression, so the base to the power in one side of the equation. 2 says take the log of both sides, and I'll explain what this means in a bit. You may need to expand the log, use the power rule, okay, don't lose track of any exponents, and then solve and check for extraneous solutions. And then one note here, rounded answers may not produce the exact same answer but will be very close. Please use 3 to 4 decimal places for any of those type of answers. For the first one, okay, well, before I look at this, sorry, I meant to explain what we mean by taking the log of both sides. So when you take the log of both sides is, let's look at number 3 first. I can rewrite this one as right, when we say take the log of both sides, we're going to use the base from the exponential expression, which is 2. So log base 2 of 2 to the x is equal to log base 2 of 61. Okay, so that's taking the log of both sides. Now what this means is, and if I cover the rest of it, I'm just worried about this here. Okay, just log base 2 of 2. So this is that expression there, that part says that 2 to some power is equal to 2, and then in this case it'll have to be 1. Okay, and if you change the base, in this case you have log of b, like they're exactly the same. You're always going to get that x is equal to 1. X is equal to 1 is like multiplying by 1, so we say that they cancel each other out, like the log and that number there. And you would rewrite this as x, the exponent, because it's x, it's still there, is equal to log base 2 of 61. The other way to interpret what take the log of both sides is, and it's the way I prefer, is it just means rewriting the exponential expression as a logarithmic expression. Okay, so b is 2, a is 61, so you have log base 2 of 61 is equal to x. All I did was rewrite this as a log, and then we did that in a previous concept already. Now you can't raise 2 to a power to get 61, so you would have to use change of base formula, and then you put this in your calculator and you'll get 5.9307. Number 4, same thing, ignore 5, there you go. 4, I already have my exponential expression on one side, so I would rewrite this as a logarithmic, or take the log of both sides, and you get log base 8 of 92 is equal to n minus 7. And then from here, there's nothing I can raise 8 to. I can't raise 8 to any power to get 92, so I have to use change of base formula again. Now I have log of 92 over log of 8 is equal to m, and whoops, forgot minus 7 here. Okay, so we could just kind of like ignore that for now and just take log of 92 over log of 8, and you're going to get 2.1745. The last step is you still have the minus 7, so you add 7 to both sides, and when you do that, you're going to get 9.1745. Number 5, I have to divide. I divided by 4 both sides first, because I have 4 times 7n is equal to 148. That gives me 7n is equal to 37, and then from here I rewrite this as a log expression, and then I have log base 7 of 37 is equal to 7. And again, I can raise 7 to some power to get 37, so I'm using change of base formula. And when you put that in your calculator, you're going to get n is equal to 1.8556. Last one here on this page, I have 4 to the 3w minus 5 is equal to 3. I add 5 to both sides, so I get 4 to the 3w is equal to 8. And then I rewrite this as a log expression, and I get log base 4 of 8 is equal to 3w. And then I can't raise 4 to any exponent to get 8, so then I use change of base formula. That's equal to 3w. In your calculators, you're gonna input this first and then divide by 3. So log of 8 over log of 4 is 1.5, and then divide by 3, you get 0.5. Let's see. Make sure we're not seeing the rest. For number 7, I have to subtract 7 first from both sides, and then I get negative 4 to the x plus 1. And then from here, I can divide both sides by negative 1 so that I don't have a negative exponential expression, and I get 4 to the x plus 1 is equal to negative 11. And when I rewrite this as a log, I get log base 4 minus 11 is equal to x plus 1. And we know that logs cannot be negative. That's from our previous concept, right? There's nothing you can raise a positive base to and then get a negative answer. So this one has no solutions. Next one, I have 10 times the exponential expression is equal to 40, so I have to divide both sides by 10, and then I get 5 to the 3k minus 3 is equal to 4, and then I rewrite this as my log, and I get that right there. Okay, and then there's nothing I can raise 5 to get 4, so I'm using change of base formula again. So log of 4 over log of 5 is equal to 3k minus 3, and then I get, when I do this in the calculator, I got 0.8614, and that's equal to 3k minus 3. I add 3 to both sides, I got this here, and then finally I divide 3, and then I get the final answer, 1.2871. Next one, I subtract 15 from both sides, and then I divide by 4, and then that gives me 3n is equal to 3 to the n is equal to 86. I rewrite this as a log, and I get log base 3 of 86 is equal to n, and then there's nothing I can raise 3 to get 86, so it's change of base formula. And then in your calculators, you'll get n is equal to 4.0545. Next one, I subtract 7 from both sides, and then I divide by negative 2. That's going to give me 5 to the p is equal to 35. And then rewrite this as a log. There's nothing I can raise 5 to get 35, so it's change of base formula. And then in your calculators, you're going to get 2.2091. So, whoops. Subtract 1 from both sides. and then divide by 5, you're going to get 9 to the v minus 1 is equal to 36. Then I rewrite this as a log, and I get that right there. Okay, and there's nothing I can raise 9 to. There's no exponent to get 36, so it's change of base formula. Okay, and I get that expression there. Do this in your calculators. You'll get 1.6309, and then you add 1 to both sides, and that's where you get the final answer of 2.6309. Number 12, I have this expression here, so I add 3 to both sides, then I divide by 8. I would get this here, and then I rewrite this as a log, and there's nothing I can raise 11 to get 27, so it's change of base formula, and I get that right there. Now input this in your calculators. Log of 27 over log of 11 is equal to 7k. Sorry, just the left side, and then in your calculators you're gonna get 1.3745. That's equal to 7k, and then divide by 7. You're gonna get k is equal to 0.1964, and you'll be done. The last two right here, first I'm gonna add 2 to both sides, so I get 6 times 16 to the 7y plus 2, it's equal to 84, and then I divide by 6, and I get 16 to the 7y plus 2 is equal to 84. No, sorry, not 84. 14. And then from here, I rewrite as a log expression, and I get log base 16 of 14 is equal to 7y plus 2. There's nothing I can raise 16 to get 14, so it's change of base. Log of 14 over log of 16 is equal to 7y plus 2. Input this in your calculators. You're going to get 0.9518. Then I'm going to subtract 2 and then divide by 7. So when I do that, subtract 2, so let's do that one first. I get negative 1.04 82, and then that's equal to 7y, and then I divide by 7, and I get y is equal to negative 0.1497, and that's your answer. For 14, subtract 10 and then divide by 3. And you get left with 84 by 3 is 28. Rewrite this as a log. You get log of 8 of 28 is equal to 3 minus 7n. And again, there's nothing I can raise 8 to get 28, so it's change of base. Log of 28 over log of 8, that's equal to 3 minus 7n. And then this in your calculators will give you 1.6025 is equal to 3 minus 7n. Subtract 3 and then divide by negative 7. You're going to get that n is equal to 0.1996. Okay, and that wraps up concept 47.